Okay, so here we shall explain how to integrate by using partial fractions with some examples. So, um, so if we have a rational function which is of the form p of x by q of x, where p of x and q of x are some polynomial functions, then so if the function f of x is of the form p of x by q of x, where uh, p of x and q of x are some polynomial functions, then the function f of x is called as a rational function. It's called as a rational function. So the degree of if the degree of the polynomial p of x is greater than the degree of the polynomial q of x, then the function f of x is called as a improper rational function. It's called as an improper rational function. And if the degree of the polynomial p of x is less than the degree of the polynomial q of x, then the function f of x is called as a proper rational function. As a proper rational function. Okay, so then um, um, so if the form of the rational function so the first thing is that if the form of the rational function is improper, it is improper, it means that suppose the degree of p of x is more than the degree of q of x, then uh, p of x by q of x okay, then p of x by q of x can be written as some t of x plus p1 of x by q of x. It means that we can then divide p of x by q of x, and then t of x will be the remainder and p1 of x will be the quotient. So if the rational function is proper, is a proper rational function, and if the denominators can be factorized, if the denominators can be factorized in some quadratic functions and some linear functions, in some quadratic functions and linear functions then um, then we can apply the following formulas. Then the following formulas can be applied. Then the following formulas can be applied, which are so first we can write the form of the rational function. First we can write the form of the rational function. So okay, so here actually we should write that if the rational function is a proper rational function, and if the denominators can be factorized in some quadratic functions and linear functions, then the following formulas can be applied to change it into partial fractions, to change that rational function, into some partial fractions, So this is the form of the rational function. Here we can write in the first column, and in the next column we can write the form of the partial fraction. So here the first one. So suppose if we have like suppose if the rational function is of the form px plus q by x minus a into x minus b, where a is not equal to b. So in the numerator we have a linear function, and in the denominator we have a one quadratic function, function which can be factorized into two linear factors. So then the form of the partial fraction means this function can be written as a by x minus a plus b by x minus b. And then if we compare the coefficients, then we can find the values of a and b. So then we have to write it as ax minus b plus b into x minus a, and then divide by x minus a into x minus b. And so then from there we can find the values of p and q. How? By here the numerator is a plus b into x and minus of ba plus ab. So that is equal to px plus q. So then, so a plus b will be p, and this b minus of ba plus ab will be equal to q. So in that way, we can find the values of a and b, and then we can uh, write the values of a and b here. Okay. And then the second case is that suppose if we have px minus px plus q by x minus a whole square, where a is not equal to 0. Okay, so then no, sorry. Okay, so here form of the partial fraction, then this can be written as a by x minus a plus b by x minus a whole square. And then we can compare the coefficients, and then we can find the values of p and q. It means that the numerator will be a into x minus a plus b by x minus a whole square. So therefore the numerator is ax plus b minus aa, and that will be equal to px plus q. And from there, so a will be p and b minus aa will be q. So from there we can find values of a and b, and then we can write this partial fractions. And then the third case is that if we have px square plus qx plus r by x minus a, x minus b, and x minus c into x minus c. So Here also, suppose A is not equal to B is not equal to C. So A, B, and C are not same. So here we can see that the numerator is a quadratic function and the denominator is a cubic function. It is having a polynomial of degree 3. So then this can be written as A by x minus A plus B by x minus B plus C by x minus C. Okay. So then similarly we can find the coefficients P, Q, and we can find the coefficient the values of A, B, and C by comparing the coefficients on both sides. So if we take the LCM, this will be x minus A into x minus B into x minus C. And then we can write it as A into x minus B into x minus C and plus B into x minus A into x minus C, then plus C into x minus A into x minus B. Okay, so therefore, if we compare both sides, then we get A plus B plus C into x square. Then minus this will be B plus C into A plus A plus C into B plus A plus B into C, that into X, and then minus this will be ABC plus BCA plus CAB. So that will be equal to Px square plus Qx plus R. Then we can tell that this A plus B plus C will be P and this will be equal to Q and this will be equal to R. So then in this way we can find the values of A, B, and C. Since there are three unknowns, we have got three equations, and then so we can find values of A, B, and C. So then the fourth one is that suppose if we have the form Px square plus Qx plus R divided by x minus A whole square into x minus B. So then that can be also written as A by, so here also A is not equal to B, suppose. So then here also the numerator is a quadratic function and the denominator is a cubic function since it is a polynomial of degree 3. So it can be written as A by x minus A plus B by x minus A whole square plus C by x minus B. So then we can compare the coefficients and then we can find A, B and C. It means this will be equal to A into x minus A into x minus B plus B into x minus B, then plus C into x minus A whole square, that divided by x minus A whole square into x minus B. Okay, so therefore this will be A plus C into x square. Then this will be minus 2A. So this will be minus of 2AC plus A plus B. Sorry, 2AC plus A plus B into A and plus B into X. Then minus this will be ABA and then minus BB, then plus A square C, that is equal to Px square plus Qx plus R. So then we can find out A, B, and C by using these three equations. Means this will be equal to P and this one will be equal to Q and this will be equal to R. So three unknowns are there, A, B, and C. So three equations, we can find out the values of A, B, and C. Then fifth one is that suppose if we have Px square plus Qx plus R and divide by x minus A into x square plus bx plus c, where this x square plus bx plus c cannot be factorized further into two linear factors, where this x square plus bx plus c cannot be factorized further into linear factors, Okay, then this can be written as a by x minus a plus b by plus it will be bx plus c by x square plus bx plus c. And then we have to compare the coefficients, and then we have to find the values of a, b, and c. It means the LCM will come x minus a into x square plus bx plus c. And then here it will come a into x square plus bx plus c plus bx plus c into x minus a. So this will be equal to a plus b into x square plus it will be ba minus ab plus c into x plus this will be ca then minus ac. Okay, so this will be equal to px square plus qx plus r. So this will be equal to p, and this will be equal to q, and this will be equal to r. So three unknowns and three equations, so we can find out the values of a, b, and c. So we can understand these formulas of partial fractions by using some examples. So suppose suppose for example it is asked to integrate integral dx by x plus 1 into x plus 2. So now therefore this 1 by x plus 1 into x plus 2, that can be written as a by x plus 1 plus b by x plus 2. So now this can be written as a into x plus 2 plus b into x plus 1 into x plus 1 into x plus 2. So therefore we have to compare the numerators. So therefore 1 will be equal to a plus b into x plus it will be equal to 2a plus b. So now therefore here there are no terms containing x, therefore a plus b, that should be equal to 0, and 2a plus b, that should be equal to 1. So it means that uh, b is equal to minus a. So we can write a is equal to 1. Since 2a minus a, that is 1, so a is equal to 1. So therefore b should be equal to minus 1. So therefore this can be written as means integral 1 by x plus 1 minus 1 by x plus 2 into dx. So this will be equal to integral dx by x plus 1 minus integral dx by x plus 2. So this will be equal to log of mod x plus 1 minus this will be log mod x plus 2 plus c. So the answer will be log mod x plus 1 by x plus 2 plus c. So this is the answer. Thank you.